All right, folks, let's get started. Welcome to Rails School on March 22nd, 2016. We're going to talk about Ruby 2.3, which came out at Christmas a couple months ago. And it's got some pretty cool new features. I'm pretty happy about it. And also, we might get a chance to see if it includes any performance improvements. I'm going to start sharing my screen here. And welcome to Rails School at Noisebridge here in San Francisco. If you are not on the class website, you can go to railsschool.org and click on what's new in Ruby 2.3. If you're logged in, you can access a shared whiteboard, which you can see down here. And we can use that for sharing links and code snippets. Rails School has been around for about 4 years, hosted by Noisebridge, which is a nonprofit, and we'd love for you to send them some money. If you can go to the FAQ here, there's a link to donating to Noisebridge, which is pretty easy. And they accept all sorts of different kinds of currency. They would prefer that you donate a recurring monthly amount. And you can also just put cash in the boxes around the space. One right over there. So, getting started here. First off, my name is Gabe. I started this class about 4 years ago. I got involved with Ruby through Rails. I still do a lot of Rails work at my day job at Binti, binti.com, binti.com, where we're helping people adopt kids and helping kids get adopted. And really like Ruby. Love that it's still adding features even after over 20 years. And the purpose of Rails School is simply to be a weekly class at Noisebridge to hack on web software and other kinds of software, including Ruby and sometimes Rails. So that's me. We have one returning student here in San Francisco, and that is Luke. Luke, what your background is as far as your programming experience and what your goals are attending Rails School today and in general?
Sure. I currently work as an intern for a nonprofit, Women Who Code.
Women Who Code?
Yeah, and right now I'm mainly focusing on building out their API. And I'm just here because I came to the one class a couple weeks ago and I really liked it. It's a good resource to learn new information, so just trying to learn as much as I can.
What was the class that you came to?
Object-oriented development, taught by Tom.
Cool. And I see this is you, Luke.
Yep.
You got a star by your name, which means you did the Cyclops numbers.
Yeah.
Might be fun to sort of quickly implement. Oops. Yeah. Okay. Let's quickly solve this. So we have to return true or false based on whether it's a number with 1 0 in the middle. So do you know in the binary representation, right? So
In our assign like string or int equal in dot 2x and then parentheses 2.
cool. So now we have like a string like that. And that is 5, right? And 5 is supposed to return true. They don't say what 0 is supposed to return. What do you think?
Probably true because it just says 1, 0 and it's technically in the middle.
Yeah, let's say 0 returns true. It's kind of annoying that they. So and then what was your strategy from here?
Do you want the way I did it or the way I did it, and then I noticed that I made it way more complicated than it needed to be?
Let's do it the more elegant way.
Okay, so the first way was to count how many times 0 occurred. 1 time.
That's the first way?
Yeah, well, to check if 0 occurs once, and then check if binary representation equals binary representation not reverse. So you check those two conditions.
I love it. All right, so binary representation. Can we just do count 0?
Yeah. Equals 1. And binary representation equals binary representation.
Very elegant. Fix num into string.
You might have.
Count to 0. Right? So it never returns true. Because I forgot to fix. Excellent. That's good enough for me. Cool. That means I will get a star eventually. So there's a little. Oh, I got honor. I like Code Wars. Cool. And I don't think Jose is here today, but it's good to see other folks playing with this stuff. Great. Let's go ahead and get started. So announcement, website for Ruby 2.3, and just go from the top to the bottom. So this is on Christmas, which is a tradition of Ruby. Let's see. This is the first stable release of the 2.3 series. It introduces many new features. For example, a frozen string literal pragma is introduced. With 2.1, string.freeze has been optimized to reduce object allocation. Ruby 2.3 introduces a new magic comment and command line option to freeze all string literals in the source files. Additionally, for debugging, you can get where the object is created on can't modify frozen string error by using the --debug frozen string literal command line option. So it's unclear to me here whether this is on by default, and we may as well just try it and see. So what would be a way to mutate this string to check if it's frozen?
Capitalize it.
Maybe with the bang?
Sure.
So that didn't raise any errors. I don't know if that's any different. But yeah, it is mutating it, huh? All right, so let's try this pragma. than substring equal substring case, and it is, right? So what is this pragma? This is not a very good link. It looks promising. Same value literals point to the same object, so that's something we can test. You're familiar with the object ID, Luke?
Like what's assigned every time you create an object?
Yeah. The virtual machine?
I've never called it like that, but usually when you create it, it shows like kind of
Yeah.
inside the
Like that?
yeah, exactly. Oh, but that's good.
I think it's just the text. Oh, you want to, let's answer that question.
What's that?
I made it hex, and that didn't make it correspond.
Yeah.
Oh, it's because that doesn't look like hex, but it is. Okay, let's just Google. Any luck on Google?
No, I'm looking right now. Oh, you're right, Brian.
Ha! That's brilliant. And we never would have figured that out. So we can turn an object ID by doing this. So it's just namespaced. It's just shifted over. Wow. I'm going to post this into the notes. I'm going to upload it later. So our instinct was sort of right, but there's a little bit of a trick to it. Nevertheless, we do have a script over here. It should work if they're not. Why not? Let's see if this blog post explains. Check it out. With this flag, if there's, I read something about oh, here it is. So it looks sort of similar to old-timey Rubyists will remember when we had to put like Unicode or the encoding. Before Rails Ruby 1.9, Unicode wasn't standard. And we had to use a magic comment to force Unicode, so it's a similar sort of idea. So with that comment, evaluates to true, without it evaluates to false. That's pretty cool. And then we could try upcase with a bang. Excellent. I think we've just about exhausted that subject. But this is a little bit controversial because people were like grumpy about having to unfreeze their strings, which I think you can just. But I think the consensus that I was able to follow was that it was for the better. And that we're going to go through like a dark age where we constantly have to worry about this stuff, and then we'll come out on the other side and have a language that's faster. Once you're frozen for good. So do bit, which should give us another frozen string. But these are frozen string literals, I believe. So that did not raise an error. So these frozen string literals are what the problem is. In other words, shouldn't we be able to do something like that? So that's actually what you would expect. In other words, this upcase bang did not cause an error because some string was not instantiated from a literal. it was instantiated with the initializer of the class and then shoveled in foobar. So that's why the only reason dupe worked. You know, if all strings were frozen by default, then we. And it seemed there might have been some like percent modifier that they gave us to create a non-frozen one. Here they're using gsub-bang to cause the runtime error.
Oh, and even your command says enable frozen string.
They do, yeah. So you can either do it with that, or as we see here, pop that flag if you have the magic comment.
Oh, okay.
Yeah. Looks like my Vim is not caught up. It didn't make it. So I'm not sure about like a quick way to get an unfrozen string. It's unclear to me whether one made it because the blog post didn't discuss it. String literal. Yeah. Uh-oh. So I'm ready to move on. What do you think? Cool. All right. The safe navigation operator, super rad. Basically, so you can play with this a little bit. String to number for 12.
Oh, it is a string.
Okay. I just wanted to create a method that might return nil. Does that make sense? So I want to add it actually works with addition. Addition's kind of funky. Obviously, this plus 12 is 24. This plus 12, that's going to freak out. What you can do is add and dot. And what happens is it just stops executing when there's a nil. And you can chain these as many as you want, right? You could do 12 plus 12. Oops, I meant to do this plus 12. I can do 36. And here we can do another chain. It'll just be stops. Something more logical would be like okay. Even if this was good. You can't change. I meant to do plus. Right. Why isn't that working? Nil can't be coerced.
One doesn't
Makes sense to do it like this.
but it worked on the last one.
Yeah, so the problem is that in this guy, we've got 1, and we're trying to add nil to 1. But if we swap it, so it's 1 and -5 over -1 over there. So are you familiar with try from Rails or active support?
No.
I find it useful. So active support gives you something very similar. Called try. Pass it a symbol, and then an argument. What's up, Edmund?
How's it going, Dave?
I guess I didn't require enough of active support. Maybe it's like extensions. Or core ext. We're talking about the safe navigation operator. We're showing how it compares to try from active support. So now this string to number is just a simple method that may or may not return nil. It returns nil if a string is passed in. For example, it's like a -1. That returns nil. Other things return. Return nil, which we see a lot of in the wild. And I was showing that if navigation lets you do stuff like this, and it just returns nil rather than undefined method. This is actually a crappy example because passing an operator like plus on the right hand side is a little bit confusing. Let's try and do number to string, right? And here we can do if n is a oh, that's extraneous because if it evaluates the false, that'll just be a. I can't remember. Is that going to what will that do for floats? Okay, so I'll let it be a float, or it could be a numeric. Numeric, I think. Excellent. That's what I wanted. Pretty handy. Okay, so if n is a numeric, make it a string, otherwise return nil. So that's more useful because more useful for demonstrating, because then you can do stuff like this. Number 1337 reverse, right? And then when we do an example where it's not a numeric, this is going to raise no method error because it's nil. But this would be like the idiomatic example. It looks less weird here than with the plus sign because we're used to calling methods with the dot. So you just put the ampersand before the dot and you get nil back. Sound good?
That's clear that way.
Yeah, it's clear that way. I was just spitballing, and the first thing that came to mind was string to number, but all the number operators are operators. All the number methods are operators, or many of them are. The ones that came to mind. Cool. So then I wanted to talk about the difference between this and okay, there's a method called try. It's actually available on every object. Once active support actually patches the object and gives you try, and then you can do things like this, right? Or this. And at first glance, it seems very similar to safe navigation. But does anybody know the big difference? It's an important difference. If you tried to do, remember this works, right? Because number to string 1337 evaluates to something other than nil. And that thing other than nil is a string which responds to reverse, right? But if you misspell it, you get undefined method, right? And it raises an error, undefined method, no method error. If you do it with the try version, it returns nil. But active support considered this years ago, and they gave you a try bang, which is actually essentially identical to safe navigation. So if you're looking at an old, once you know that you're happily on Ruby 2.3, you can just blindly replace try bang with the safe navigation, which will save you some keystrokes, and also could mean that you no longer depend on active support because it's core Ruby. Do you have any questions about that?
So I'm curious, the source code should be C instead of Ruby.
Yeah. Oh yeah, totally. That's a good point. we can look at I should let us do something like this. Yeah.
Oh, shit.
Because it's already gone. But so this is actually pretty easy to understand. This is a little bit golfy though. It's not that easy to understand. Actually, it's a little bit clever. The way this is written, it's written by somebody who didn't care about it being easy to read. But basically, if you're me or you, like ordinary people trying to read this, rest assured that if this evaluates to false, you're going to get nil back, which is not a bad thing, right? Because try is a method that often returns nil, right? So you're going to get nil back if you tried to call try with an empty string. That's pretty interesting. I didn't know that. This should give us nil every time, which makes sense. You can't have an object. You can't have a method that's called the empty string. I'm sure checks whether the object responds to that method, right? And if it responds to that method, it's interesting that it only has to respond to the first method if you pass in several arguments. That's pretty wacky. Now I'm curious what try does with all those arguments and what the block does. Let's go ahead and show method. It's interesting. It doesn't seem that exciting if you're only doing one. I wonder if we can pass in reverse twice and it'll come out the same way. Given one, expected 0.
What if you use a method that takes a method, takes an argument? String, yes, it's
Okay, so it's passing that as an argument to reverse. To reverse, actually.
So reverse doesn't take argument.
Exactly. So what's something that does?
2s. You can pass in 2.
Yeah.
Does the string 2s take argument?
No, a number would. Let's try it. It should. I think that's the problem.
Oh, yeah, exactly.
Okay. So what if we just do this? Okay. So, oops. Wanted to show method. This guy again, because now it makes sense. What I was wondering was, why does it only care about the first one, right? For exactly anything else's arguments. And so it defers to later. So any questions about that? So-called lonely. That sounds like so Japanese. Doesn't that sound a little bit Japanese? A little bit? Seems Japanese to me. Cultural insensitivity. Did you mean? We've already seen did you mean, right? RVM, jump set, create, throwaway, and use throwaway. So did you mean is a dependency of Ruby now? I'm not sure if dependency is the right word, but it's included with Ruby. So, oops. You can install Pry now. My new gem set. It's not installed globally. Now, when we do foo.reverse, did you mean gem is responsible for doing a fuzzy string match to try and help us find the method that we were looking for? I don't know any tricks to it. Minutes saying, did you mean gem tricks? I'd argue it doesn't save us from typos, it just makes our typos less painful to fix. It finds constants, it finds instance variables, it finds class variables, finds method names. I want to just what is describing here. Okay, so it was saying up here, okay, so what's not experimental is looking for a local variable like this. It should say, did you mean? Beautiful. But then they have an experimental one you have to ask for. Not working for me. Oh, when you call a method on it. It's not working. I guess that's why they say it's experimental. Maybe if I have to initialize it, no. Maybe if I reinitialize the correct one, the gem is paying attention. No, this doesn't work for me. Maybe this is not yet made it. This is not that exciting to me, truthfully. But I mean, anything to make the language more friendly to noobs, I think it's it doesn't really appeal to us, but like, I think it's really out, so it can be very discouraging. Oh, we learned this earlier, Edmund. Super silly. We were trying to figure out how this hexadecimal number in the 2s of an object relates to the object's object ID. And the simple fact is that that this is namespaced is not namespaced. the value is namespace, which is object ID, which is always shifted one bit over with a 0 on the right hand side. So you can always get a value space ID from an object ID by shifting it over. This is pretty obscure.
Is that a object ID? No, is that an object space ID? I thought that's like a memory location. But where the object full colon
Yeah, they're the same thing. This is just in its value form and in its object space form. It's pretty wacky. Not super important. Like we've all done plenty of Ruby and not had to deal with this, but it's like a curiosity. And we checked it out. This actually works. Cool. Ooh, all right. We forgot to do array.dig and hash.dig. These are some of my favorites. It's going to be brutal. So you need to do some fancy stuff like this. Pretty wacky. Anybody spot my mistake?
42, 43 as well. 42 and 43. Like 2 lines.
Yeah.
Yeah, 43.
Should be closing the array now.
I thought it was chill. Oh, I forgot the dot /. We got a nested array. Yeah.
Nested,
Nested.
instead of nesting.
Because it's local. Okay. 0 on this, right? We can call 1 on this. And then we can get the 1th and keep going in at 1. And then, oops. Zero, 1, 0. Okay. But what if we wanted to do it in a sectier way? I think we can now do something like this. And I think we can even So you want to see if something's down there, but you don't want it to explode if something ain't down there. And you don't want something obnoxious like this. And you want something that maybe is like more conducive to like meta programming, right? Because here you could do why isn't this working, folks? I created a path. I'm creating a path that's just following the it's like depth first. Okay. So what I want that to do, I want to be able to like meta program it like this. Okay. It was working for it. Now I'm just
For the
confused.
first one should be one. Yeah. There we go. There we go.
But we found that this would give us, right? So how come?
So if you hit a fix now, then it'll give you an error.
Oh, thank you.
Good catch.
Huh.
That's a good catch. Okay.
What if you put the safe lock there?
You can't, it's just not a good fit because it has to go in there. But what if we did something like, what if we had some bit string like this that we split on the empty string, right? Then we could call nested array dig and splat that. You familiar with splat, Lucas? If we pass an array to dig, it might work actually. No, it doesn't. Dig doesn't want arrays. It wants a series of arguments, right? And the splat is the general purpose operator that turns an array into a series of arguments.
Candy strings.
What's wrong?
Candy strings. Try to adopt from that and change all this to.
Oh, thank you. Okay. So now we can profit. So that's pretty cool. Dig lends itself to metaprogramming in a way that without this, you would have each like we could do that, but I don't want to. Yeah, it would be like we could reduce nested array. It's actually not that ugly. But this is much easier to understand. If you wanted to metaprogram traversing an array, it's much easier to do it with dig, which is semantic, because it basically means, hey, I'm going down this path, seeing what I find. Whereas this is like very cryptic. What's more exciting than nested array is so do you know within different access, Lucas? You've used this, though you don't know that you've used it. But if you have a hash that looks like foo3, do you know the underscore in pry for IRB? You can use it to get the last return value. So you could set h equal to underscore. And you can index this hash with the symbol foo and get 3. But when you try and index it with the string foo, you get nil. So active support gives you within different access, which basically means treat symbols and strings the same. It actually, under the hood, it does save them as strings, I guess. But it treats symbols the same, right? So basically, I wanted this nested hash to be, I wanted the shorthand of like that JavaScript like notation. It's very fast to write, but I didn't want to have to index it with anything in particular. I wanted to be able to index it with strings or symbols. This nested hash. And in the past, if this was like something, maybe call it params. In Rails, you see this terribly obnoxious pattern that's like params user, ampersand to ampersand, params profile, ampersand to ampersand, params user profile photos ampersand equal foo. Escape. You ever seen this in a? You do see this. because Rails forms likes to send nested parameters down, which is not a bad thing in and of itself. But with just Ruby and Rails, you wind up with crap like this, which sucks. Because it sucks to read it, it sucks to break the lines, it sucks to write it, it sucks all around. So Dig makes it literally this. Super nice, right? And it doesn't, it's just a hash, so it doesn't care whether they're symbols or whatever, you know, because it's defined on hash, you know. And if any of these keys, this key is missing, it's nil. And let's see if that what happens here. It seems pretty forgiving. Super useful. Way everybody realizes that this is the same as this, right? That's what inspired it, because the Ruby people were going to add the safe navigator. Other folks were like, whoa, if you're going to add that, you should also add other helpful stuff, right? So that we don't have to do crap like this.
That profile in the parentheses after the director, just put an empty director.
Nice. Horrible. So we're really glad we got the dig. But you see the theme. So it's actually in the same paragraph because all this stuff is related. Ruby V. There's let's play with this.
Into what? You see.
We can compile our dig file. Okay. So our I sequence is there. And then we could presumably dump it to disk. So we could write it with let's go ahead and write it to binary. So compiled Ruby I seek to binary. It wrote 3K. And unless it's not going to be very pretty. Then it's fun to call strings on it. Binary file, folks. This is pretty cool. Are you familiar with strings, Lucas? Strings is you pass it a binary. We'll load from binary file.read. What do I call it? Binary Ruby. Compiled Ruby. So our I sequence is here, and I wonder what kind of methods we have on it. We can evaluate it, right? So remember, nested array, it's undefined, nested hash, undefined. Presumably, if we evaluate this instruction sequence, we get our nested array, nested hash, and it returns the return value of the evaluation is the return value of the end of the file, and when you define, it returns a symbol corresponding to the method name. So we're back. We should get the code back out of the ISEC, right? That's the abstract syntax tree. What about maybe the ISEC doesn't store, maybe it stores the syntax tree, but not like the formatting, like the exact white space. It would make sense, right? Why should it? This is some intermediate representation. So these are the assembly language commands of the Ruby virtual machine at some level. Yeah, so I'm just going to go ahead and say it stores the abstract syntax tree. It doesn't store the source code. If you were Ruby, that's pretty cool.
Does that mean that you can?
Your users would be super trusting of you.
No, but how about just deploy to the internet?
Yeah, that should be no problem. Should be no problem.
So does that mean it's going to be fast this way? It's not going to be compiling in real time?
I don't think this is the bottleneck. I don't think this is the bottleneck because all that source code, when you launch the interpreter and you require your app, say it's a big fat Rails app, all of it is loaded once when you start your app. So your app might start faster, which could be nice. It would mean like less downtime if you're waiting for your app to start before users could start using it. But
no, but isn't Ruby code being compiled in real time when you actually get to a certain line of code and then it turns that line of code into C and then execute C?
no, it doesn't turn it into C. It turns it. This is actually a really good demonstration of how it works. It creates and Lex is after Lex. To this, which just feeds into the virtual machine. Not preloading things that don't need to be preloaded. In other words, that's a way that Rails can sort of pretend to be a faster starting up. If it loads all the stuff and then it waits till a constant is invoked and then the autoloader finds it and loads it, that's just a bunch of extra crap on top of fundamentally, once you load it, it's loaded. And you don't have to reload it until you kill your process and start anew. Many performance improvements like that. and that became like CRuby or MRI Ruby, what we use today. So he usually only pops up in like the more language implementation and performance side of things. This must be a pretty exciting thing. He's trying to help us understand it. It's pretty cool. For methods defined classes, then owner of these methods are also defined class. Foo's owner is C1, and Foo's defined class is C0, right? It's implied because super would throw undefined there if it wasn't defined on C0. So there's the distinction between the owner of a method and the defined class of a method, right? The owner is when you call that method, where is the inheritance chain going to start? And the defined class is if you go all the way to the top to the first class in the hierarchy to define that method, that's the defined class, is what I'm understanding. I don't know this stuff. So you're in Foo and you're looking for the superclass. So the first thing you would look for is C1's superclass. Well, that makes sense. Now he gets into modules. Foo's defined in a module, but it's unclear at the point where that method is defined, the defined class of Foo. In other words, module M could be mixed in to any class that has an ancestor or itself that defines Foo. So the options are very large. So inside module M, we can't search the superclass because we haven't been mixed in yet. And then when you include M, that determines the superclass, right? So I guess Foo's owner is still M, but in this case, the defined class very clearly is C0. Right? It's not C1 because C1 doesn't define Foo. Therefore, it's actually not clear that it's C0. We know it's not C1. We know it's either C0 or one of C0's ancestors because he's changing things on the fly. And he doesn't show us the definition of C0, so we don't know for sure that C0 defines Foo. And it's worth delving deeper into like Ruby's object hierarchy and how it distinguishes between inheritance. Ruby has single inheritance, so methods can be defined by superclasses, but it has multiple composition via modules. Once you start playing with it, it'll become pretty familiar to you. That when you're starting Foo in C0, the first place it looks is on C0, and then it looks on the included module, and then it looks on C1, right? Which is something you need to familiarize yourself with. Otherwise, you don't know whether it's going to call, who it's going to call first. We can't determine defined class of the M instance method Foo, but we can determine the defined class included module Foo. So you can determine a defined class once the module's been included. In this case, it's C0, just for the purpose of demonstration. I can't get into all this, folks. Like, it's not going to be useful to any of us. Like this is structure. Table. And we use it for many things. Like we use it to store where methods are defined. We use it to store where constants are defined. So it's like literally a table that's, you know, if you have a constant like somewhere in the virtual machine, there's a table that gives you back, that takes 2 and gives you back 3. Introducing this new table, having to store the hash value. Optimizing proc.call. Okay. Oh, another Koichi one. So basically, the most, if you can skip a method call, you can skip some clock cycles, you can skip some space on the stack. It's a good thing. So it's noble of Koichi to investigate this. He says he thought he figured it out years ago, but it broke Ruby. But now he tried it again, and Ruby is not broken. So you can see by the stack trace that prior to the patch, we're at line 5, which is confusing because I only see 3 lines here. But presumably that's the last line. And we're evaluating this chunk of code. We call the call method, and then that puts us in here, right? But he was able to do some crazy voodoo ninja stuff so that now we go straight from here to here without object send already has the same technique. So there's places where you call foo.send, and you don't see the send call in the stack trace. Seems pretty wacky to me, but I'm sure you just got to trust. Actually, nobody commented on this, so who knows? Sometimes it's fun to look at the patches themselves. There is a link here to the patches themselves somewhere. Oh, thank you. No, it's the same thing. I swear. You have to be logged in. It's kind of weird. Comes all the way from Japan, so that'd be. How big could this diff be? While we're waiting for that to load. Oh, here we go. So this is, by the way, how you comment something out and see. It's pretty sketchy that he committed this. He knows better than I do. This is it. It's just commented out. He's commented out. Oh, he deleted some stuff. Okay, so it's really confusing. Circuit this, and it got failing tests, so he just commented it out, but put it in the trunk, and then now he tried uncommenting it, and it worked. So he's just uncommenting it. So he deleted the else, and he left uncommented this stuff, where instead of but if it makes our Ruby faster and the test still pass, I'm happy. Machine code level tuning for object allocation and method calling code, smarter instance variable data structure. So if you have an OpenSSL server and you have 9,992 accepted clients, on this person's benchmark, this reduced the resident memory usage from 77 megabytes to 69 megabytes. It's pretty cool. They're saving us memory. It's 2 patches. Let's see. Combined with patch. Um, this looks pretty messy. 2 revisions. And they're changing the headers of internal, the Marshall code, time code, variable code. This stuff's just gonna be a mess. We're gonna have a hard time. This is interesting. This is just one. Sometimes pull requests are kind of nice, huh, folks? Yeah, screw this. Smarter, okay, exception false. And IO waitable are too common in socket applications to be the exceptional case. Datagram sockets, who knows what a datagram is? Let's Google it. Datagram is a basic time and order of arrival need not be guaranteed by the network. So it's very low level. Sometimes the what's the analogy people would use would be something like you were a maybe you're an FM radio station and you're just sending out over your antenna some music, right? And you don't know whether people are listening, but you're sending it out. It's not a great example because the order is sort of linear. It's like an analog signal. Better example would be like, well, let's make it concrete, folks. What's the protocol that we associate with datagrams in the internet? What's the one that's not TCP? TCP is a level, is higher level. And the way that you know that TCP does make guarantees around, it mostly guarantees that it'll keep trying until you get it. So there's another one that's sort of like the little brother of TCP. It has datagram in it. So it's a 3-letter acronym. D is the middle one. UDP. I think it's Universal Datagram Protocol. And actually, for instances like this, I usually have this really hilarious joke about UDP, but you probably wouldn't get it. Super cheesy. So we use UDP for things like streaming video. If you think of like the Super Bowl being streamed online, right? That's basically a situation where you know you're going to max out like a bunch of infrastructure. So you don't want people streaming over TCP, where every frame of the Super Bowl you have to acknowledge it back and forth, because the overhead of all that acknowledgement and the state that you have to maintain to be like, all right, Lucas got these N frames, and Edmund has these M frames, so you need to find this frame and send it to Lucas, and find this frame and send it to Edmund. You don't really want to think in frames because it's all compressed, but the point is that when you have a very high demand on like a real, like a soft real-time situation where people are going to complain if their Super Bowl feed is delayed by any amount of time, that's noticeable. That's when you would pick up something like UDP. So lots of times like streaming video. Anyhow, it is super useful. And also, when else might be useful? It's lower overhead. Under what circumstances would you not necessarily require these guarantees? If you have if you own the link, and the link, and you can characterize the capacity of the link, then you don't need the acknowledgements. If you own it and you know that it's high quality and you can know that it supports this number of packets, just send the packets, right? If the system isn't working, then you have to go back and figure out what's wrong with your link if you own it, right? So like, for example, with machine, right? If I have process A and process B and I want to send data from process A to process B, then skip the overhead, right? Because I trust my stack from head to toe. You know, this computer, like, it's not going to lose packets because there's nowhere for them to go, right? So UDP, in very friendly circumstances where you control things and you know what the capacity is and what the quality is, even if you control things and you know that every 10th frame gets dropped, you could just send everything twice and your chance of actually losing something would be very low, right? It would be 1%, you know, the compound probability. So depending on the overhead of TCP and the state and the bigger frames, you might decide it's actually smarter to use UDP in that instance. So these Ruby folks are claiming that they're trying to stream datagrams across sockets. They're trying to stream datagrams across ports, you know, like localhost 3000 is a port, and you can listen for TCP on that port. You know, it's baked into your kernel. This is like the networking stack of your kernel. Or you could listen to UDP on that port, right? It's no problem. So obviously, or not obviously, oftentimes, like we're writing web stuff, we're using HTTP. HTTP lives on top of TCP IP. But if you forget about HTTP and you're looking at lower level stuff, you can use Unix sockets, which is its own protocol, or you could use UDP over IP over a port. And you can do that with Ruby even. And what Eric is claiming is that with sockets, we already have like a nice API where we can read and write to sockets without blocking. I don't know how this works, but presumably not blocking is a good thing, because when you're blocking, you're not using other resources, like mainly CPU, until the IO finishes across the socket. So Eric is claiming we should have the same luxury of reading and writing in a non-blocking fashion over UDP. That's how I interpret it. And what he was replacing was something where exceptions occurred, which were very expensive. And presumably slow clients were causing exceptions, which have to be managed in a blocking fashion. So he refactored it so that they're not causing exceptions and that it's non-blocking. Sounds pretty cool. Exception false keyword argument support. So you have to ask for exception false. So it's sort of like backward compatible. Like if you're expecting these socket methods to raise exceptions in your legacy code, you just carry on. It's not going to break that. But if you're writing new code and you want them to not to raise exceptions, you can opt in. Cool. And let's go back to that blog post and just review some of the benchmarks that they did. I'm not sure if it was right before you got here, Edmund, but there was somebody put together like a pretty decent blog post on Ruby 2.3 performance. So they focused on immutable strings, but there's some benchmarks towards the bottom. Run a series of benchmarks to see how strings immutability impacts on object allocation, garbage collection, and performance. Let's take the following snippet as the starting point for the benchmarks. 1,000,000 times instantiate a string A. Without immutable strings, we're stuck creating 1,000,000 A objects, right? Which is writing a megabyte to memory and writing, indexing where we're storing these bytes in memory somewhere in the virtual machine.
What's that GC's does it actually open up the garbage collection?
Yeah, it's actually that easy to disable the garbage collector in CRuby. What they're doing at line 4 is,
This is when?
this has been around a while. Yeah. So for you would never want to do this in production because you run out of memory, unless it does give you a sort of hacky way to sort of implement your own garbage collection schedule if you know what you're doing, but it's not advised. Here we're disabling it because we want to get a more accurate benchmark. In other words, the garbage collector is unpredictable. If it happens to fire during one trial but not during another trial, that's sort of adding noise to the benchmark, right? So they disable it. They that must be a okay. So they're comparing 1,000,000 times calling a no-op block. No-op is what we call a block, a piece of code that doesn't do anything. So here you see that that calling the no-op between immutable and mutable is essentially the same. It's off by 1 for some strange reason. Let's not get caught up in that. But passing a string literal instantiation A, we see that it's almost as though it's a no-op. It's not a no-op. So seeing it go from 5,328 to 5,329 here, that makes perfect sense. That's that one A that we had to store somewhere, right? But over here, you see that we added 1,000,000 A's. So, this is obviously like not very there's not that many applications where where you're using the same string 1,000,000 times. It's kind of strange, but I'll take it. And let's see what else is going on. Now let's remove object count and enable garbage collection and see what gc.stat has to say. gc.stat will return a hash with garbage collection statistics. The keys we're interested in are count and total allocated objects. Triggering garbage collection before running the loop will create a stable and clean scenario as garbage amount will be minimum. So according to gc.stat, with immutable strings, we brought down our number of allocated objects from 1,057,000 to just 57,000. And rather than running the GCs 57 times, we ran it 6 times. So that's nice. Create fewer objects, your GC has less work to do. It's nice. Let's see if this saves us any time. We're just going to benchmark it. And they found benchmarking it, no difference, a small difference. I don't think it's super trustworthy because it would be nicer if they did like 100 million, in my opinion, because just our clocks aren't that good at this level. But they're claiming that this is valid and that we're resulting in 37% less time used. We're hoping that this will help with template processing and database query generation. Certainly in Rails, we do a lot of these things that involve a lot of buffers of strings. And so you could see where a string that contained, for example, select might be reused frequently. So that's sort of helpful food for thought to conceive of how this might help in the real world. Cool. Oh, I haven't been screen sharing this whole time. Lame Google Hangouts. I'm gonna say goodbye to y'all. Sorry about the hangout.